Great, so now let's start part 2, reservoir system, and in this one is a similar system of the one that we were working before. So in this system what we have is the same 5 users, so 4 users, the river, user number 1, 2, and 3, but now we have a reservoir here, and we want to and they have exactly the same priorities. First the river, then user number 3, so first the river, then user number 3, and then users 1 and 2. Okay, so that's their priority. So let's actually see, as you can see, the river, it has, we're going to estimate how much water will be left in the river. Now we're splitting that water in the river as only the water diverted from the reservoir to the river and then the spills. Okay, so that's why it's different something here. The other thing that is different, that if you remember in the previous case, the water available, it was Q in. Okay, but in this case, the water available is ST minus 1, so the previous storage, the storage at the beginning of a given time step or for the month, plus the water coming in during that month. So that is the water available. That's the main different things from this exercise to the previous, that what in any place that we, before we type or that we wrote Q in, now in this case we're going to be writing ST minus 1 plus Q in. Okay, so in this case, how much water can we left to the river? So water extracted from that reservoir going into the river, it can be again from 0 to 1 or 2 units. And remember that it can go above 2 units, but that will count, we will count it as spills. So it will be from 0 to 1 in this case if this water available, which now it has changed, ST, if this ST minus 1 plus Q in is less than 2. And in this case, how much water are we gonna take in here? Remember that in the previous time it was only the water available. In this case it will be ST minus 1 plus this water coming in. So this is water available. So if the water available is less than 2, so if the storage in the reservoir plus the water coming on that month there, if that is less than 2, you're gonna leave that water to the river. Otherwise it will be 2. And when can this happen? Well, if this is the opposite, if this ST minus 1 plus Q in is greater or equal than 2. That's when it will have those 2 units. Now, how can we account for the spills? So in this case, let's think about this. So when are we going to have any water, any surplus of water that the reservoir is already full, and we're going to have water spilling all the way and passing through here? So when will that happen? So the reservoir will have no spill, or it will be spilling. So no spill. And again, I'm trying to go to these two kind of different extremes. So when it will not spill, that will happen if this available water, if this ST minus 1 plus Q in is less or equal than, so if the previous storage plus the water coming in is the storage capacity, which in this case the storage capacity here is K, plus the water that these 2 units, the water allocated for the river, plus the sum of the human water users. So when the water coming in is less than the storage capacity, which in this case is 25 units, plus the water to the river, plus the water to the, so when that happens, if this available water is less than this amount, so 12.5, 25 plus 12.5, 37.5, when that happens, then the reservoir will not spill. Why? Because it will store that water and then it will deliver 2 units of water here, 5 units of water here, 3 here, and 2.5 here. Basically, the river will store all that water, it will get full, and but it will not spill. So when will it spill water? Well, when the opposite happens, when St minus 1 plus Q in, so when that available water is greater than what I just wrote above, which it will be this river plus the sum of all the water demands for all the human water users. So that's when it spills. Now, how much water will it be spilling? It will be spilling this minus this. It will be spilling that extra amount of water. So it will be spilling St minus 1 plus Q in. It will be spilling this available water minus this that we have in here, which it will be K plus Q river plus the sum of all the water demands. Okay. That's when it will be spilling water. Okay. So it will be spilling, which is, this will be the amount of water that will be spilling. And in this case, this amount is what I just wrote in here, this below what I'm writing here. So this is how much water it will spill, and that will only happen when this occurs. Now, as I mentioned, for user number 1, for user number 3, it is exactly the same allocation. Rather than now having this Q in, it will be St minus 1 plus Q in T. The same this, it will be 2 less than St minus 1 plus Q in less than Q river plus X3. Because remember that in the previous one we only have here as this Q in, this water upstream, it was the only water available. Now we have the water available is the previous storage. So the storage in the previous time step plus the water coming on that month. And in this case it will be, rather than only be here, it will be St minus 1 plus Q in if it is greater or equal than Q river plus the water demand for X3. So it will not be this. It will be this water, which is exactly the same. I'm just adding this ST plus 1 when I'm seeing a Q in. And the last one, it will be the same. Rather than having this Q in, it will be this plus ST minus 1. This will be this one plus ST minus 1. And it will be this one plus ST minus 1. Okay? And then in here it will be exactly the same. If this it not will be Q in, it will be Q in plus ST minus 1. So this would have to go in here. And similarly in here, it will have to go Q in plus ST minus 1. And the same we will have to, this will be plus ST minus 1. Here this will be this Q in plus ST minus 1. And then it will be this plus ST minus 1. This guy here. Okay? Hi, okay, for the last part, this is just to provide you some guidance on how you're going to solve part 2 of the reservoir. So as I mentioned, first you will have to declare similarly the names of the different variables that we're going to be using. And the names are here. So in this case, you will have to go to formulas, define a name, and this will be the same, river WD. In this case, we're going to save this one here in this reservoir, and it's already CV54. For the next one, we're going to call that one X1WD. We're going to be saving it in reservoir, and it is that one. For the next one, it will be the same, X2WD. We're going to put it in here, and it is that, and the last one will be X3. And for that one, we're gonna X3WD, save it in here. That is correct. We're gonna save the storage capacity. And for that one, we're gonna call that variable K. It will be in this variable, and it's already in here. And hedging. And that last one, it will be the same hedging. We're gonna be putting here in reservoir. And it is that one. So we already have saved that. Similarly, we're going to be start working in here. Then we're going to fill this. And then at the end, we're going to estimate the reliability, vulnerability, resilience, all of those metrics there. So once we have declared all of this, like, which is what I was doing in here, yeah, you can actually double check that they are there. And that will be in this manager. So you can see that we have all the different ones. Now they are double because basically some of them are in the river, part 2 river worksheet, and some of them are in the part 2 reservoir. Okay. First, something that you can do in here is copy this one. It will tell you that if you want to, that a variable similarly like this already exists in this one. Do you want to use it? Yes. Similarly will be with the variable x1, x2, and x3. So we are reusing the names here. So you can see here when you double click on it, it's already calling the variables that we were using. But in this case, river will be equal to, so the river will be equal to 2 if this is greater. So if Q in, so if this available water is less than 2, so if this ST minus 1 plus Q in is less than or equal than 2, then it's only less. If R is less than 2, then it will be that amount. Otherwise, so if this happens, if this available water is less than 2, it will be this available water, Q in plus ST minus 1. Otherwise will be 2. So that's what is going on there. Yep. So that's what he's doing right now. He's just filling those values there. Now for user number 3, well, we also need to start working on the spills, which I think that will be very wise to do. So in terms of the spill, what we are doing here is that if this, so we will have to do first when it's 0 and otherwise when it's this. So if this available water here, so ST minus 1 plus Q in is less than, and in this case it will be K plus river plus X1 plus X2 plus X3, so the storage capacity plus the river plus X1 plus X2 plus X3. So if that happens, it will be 0. Okay. Otherwise, it will be this available water, which is B6, minus all of this. which is K storage capacity plus river plus the sum of the three water demands. So there you go. That's what we have it, and that's when we are gonna start having some water, some spills in there. Okay. So I think we're good. We have already a river and then also the reservoirs. For the other ones, for user 1, 2, and 3, we can copy those formulas or borrow them for the previous one. And again, if you remember, so rather than now being this in the previous one, it was only Q in. In this case, that's what I was explaining. This will be, this value is ST minus 1 plus Q in. So the available water just changed, as I mentioned in here, but you can use exactly the same equations. So that will be how to calculate for all of them their water allocation. So if we go back here, this is something very interesting. As you can see, we have already estimated this one for the previous one, this water allocation graph, where you, depending on the water available, is how much water each of them are receiving. This is exactly the same. But this one, what it relates is, so depending on what is your previous storage plus the inflows, that's how much water you're going to be releasing. So this first part, here you're only releasing in this portion up to 2 units. But then when this start coming in, you can see that now you start up to 4, 5, 6, 7. So when you're here in 7 units, you're also delivering 7 units of water. So when you have that 7 units, this is a one-to-one chart. So what is basically doing it is that it's just supplying, delivering that any unit that you have available there of available storage plus water Q in, it's the amount of water that is being released. And then once you have hit this 12.5 unit, then you just have to release those 12.5 units to meet all the water demands. And then here the reservoir will start spilling. So again, once you have estimated those, you can come back here. And so in this case, what you need to start doing it is estimating this ST minus 1, sorry, this ST minus 1 plus Q in. So in this case, the ST minus 1 is the initial storage, okay? Which is this, also this number 7. That's why I leave it in there. Plus the Q in, which is this. So that will be your water available. Considering that, you can copy the cell. So right now we are in that part 2 where you can copy the formula, and basically this will be, it's now taking a look at the available water and seeing if it's going to deliver its full amount or not. Again, anything that is in this column that is greater than 12.5, everyone will get their fair share. So in this case, the storage at the end of this, it will be equal to this so in this case it will be this one, which is the formula that we're having here, minus the sum of all of these. So what is what's left on the river, so the water going out. That will be the storage for that one. We can also estimate if there will be any spills, which in this case it will not happen. So sorry, this is the column of the spill, sorry. When you're estimating the spills, something that you have to find now, because it moved a little bit from the previous one, you have to move to refer to this ST minus 1. So by doing this, as you can see, we don't have any spills in here. We can use all of this and fill the table. Now this is the performance again of the entire system. As you can see here, compared to the previous one, well, we now have the river become more stable compared to the previous one, where the river it was a little bit more, it had more variability. So now we have reduced all the variability, and these are all the spills that are occurring in here. Then we will also have all the different you can see that user number 3 now, in the previous one, it had 2 periods with deficit. Now in this one, it only has 1. This went for many different years with a deficit. If do you remember, we already estimated and we find out that they were 11 periods with deficit. And now in this one, you can only see that it only has only 2. So that's no wondering why people build reservoirs. Basically, it provides a reliable water supply for human water uses. So we can estimate the same here for these, the different water supply deficits and resilience. So in this case, we can have to click here, yes. So the variables are going to be in here, and yeah, you can see here that pretty quickly we were able to estimate that here they have only 2. This, it only has 1 period with deficit, which it was this. Then something that we're going to be doing here is estimating all the different parameters that are here below. So again, we know that there are 29, only 2 with deficit, and this one only 1. In this case here, 19 periods without deficit, here only 20. This will be the sum of the deficits, the sum of these two. This is the sum of the water demand, and it should be exactly the same as the one that we have in here. And then this is the sum of the water supply. Okay, so which is the difference between this minus this. We can estimate also the resilience matrix. And again, when it failed, it only recovered until here. That's why we have these 2 ones. And when it failed, it recovered. That's why we have a 1 here. Last but not least, we can estimate the reliability, resilience, vulnerability, and sustainability index for all of them. So again, here we have a 0 vulnerability. So now look at this, it went all the way to 100%. Now the problem is that we have a river that is very stable. So that will not be adequate for the river. The performance of user number 3, you can see that it went from 71 to now 72%. It has very similar numbers as in the previous 95, 97. So here it increased a little bit in terms of the reliability. So before it has these 2 of 7, now it has this only one of 3.5. So that's why it increased here in terms of volume. The vulnerability is about the same. So what that means is that when it happens is 3.5 the average, which it is here also 3.5 the average, but that represents 70% of vulnerability. When it failed, it recovers, it has 100% of resilience. That's why it has slightly better numbers because of this reliability in volume. And you can see that these other two went from user 1 and 2 from 44 to 52. Now this will be in terms of estimating all these different performance criteria. Something that it is possible to do here is to, rather than so this will be the end of your exercise here, and you will have to respond these questions. If you want to get some extra credits, this is how you can get some extra credits in this exercise. So if you have stayed until here for this video, this is how you can get some extra credits. So what you can do is, rather than actually having this as a 1-1 relationship, you can release less water and save it, and so when the reservoir is at this level, start releasing less water to see if it will get filled a little bit better. So in this case here, rather than doing this V6, which is this, you're going to multiply it by a hedging factor. Okay? So in this case, what I'm going to do is to substitute anything that says B6, which is the cell in here, this cell B6. I'm going to substitute it by B6 times hedging, which is basically the variable that we have in here. So I have replaced these ones. So as you can see here now, everything that it has a B6 is B6 hedging, and so on. So we can do the same in here. We can do the same in this one, and we can do the same in this one. In the spills, I don't think it's needed. So once we have done that, again, we can calculate all of them, and as you can see, nothing changed. So we didn't make any change in the calculations. Well, that's not true. Basically, here is still having that factor of 1. We can, let's say, we divide it by 5. So as you can see, in order for the user to have, so rather than let's focus on here on the river, okay? So before the river, we know that it has a unit of two units of water demand. In the previous, when we were doing the previous values, we know that when there were at least 2 units of water in this kind of previous storage plus Q in, it will be diverted to 2 units of water. So this was linear: 1 unit, 1 unit, 1 unit, 1 unit, 2 units, 2 units, and then 3 units, 2 units, and so on. When you put this factor to 0.5, now you will need to have double the amount of water, in this case 4 units, to deliver 2 units of water here. So you are, once you pass this specific storage capacity, you will be cutting every water use by a proportion, the rest of them by this proportion that you're seeing here. In this case, it will be to sustain that specific, to save some water and see if you can come back faster from a deficit. So that's what this is doing. Now, what I need to do here is to update the values for these guys here. And I think that's it. The reservoir spills, they didn't change. As you can see here, now that we have changed this value, this is how it looks. A lot of water is now being spilled. So this is only with 1. I think, copy these ones. Oh, I see. Yep. So as you can see here, so let's focus on user number, well, first with the reservoir. It will go from, excuse me, from the, for the river, this volume of water here. So it will go to all these spillings to a lot more spilling. So because it's saving a lot of water, and then you have a lot of water at some point here, it will be just spilling. Let's take a look at user number 3. So this is its water supplied. And actually in this case it changed because it starts kind of curtailing water. So in this case, these guys will receive more water. User number 3. User number 1, so as you can see, they were having, with the hedging policy, it will be having these only 2 times of water deficit. And as you can see here now, they have more times. And that's because as we're putting this threshold when you're going to be curtailing, they are the first one that get curtailed. So because they get curtailed first, that's why this user can use more water later, because more water is saved there. So this is the hedging policy. Thanks for being here. Get some extra credits, get some extra points. Have a good one.